Hello everyone, how are you all? I do hope you are all well. This is my first video lecture after we are locked down. In this lecture, in the last of our few classes, we have already learned about moments, raw moments, central moments and so on. And of course, we have already done some problems from this context. Yet, today we shall recapitulate again all these because today I am about to introduce a problem from this context. So let us now start. What basically the moment is for a statistical observation. Moments. Here we have assumed n number of observations, statistical observations, x1, x2, so on, xn. Of course, this is without having any frequency, and these are in number n number of observations, and we are defining the earth moment. Here we have considered an arbitrary constant, capital A. Constant means a real number. Arbitrary constant, capital A. And we are calculating the moment of these observations with respect to this arbitrary constant A, which we have considered here, and the moment is the earth moment. That means we are calculating the earth moment about this real constant A of these statistical observations. And we are defining this earth moment as this. You all know this. I have already discussed when I was physically present in your class. So everybody know this. I am recapitulating. So the earth moment about A of this statistical observation is basically equal to 1 by small n summation over I equal to 1 to n summation over I equal to 1 to n xi minus capital A whole to the power r. So earth moment about A of this statistical observation x1, x2, so on, xn is 1 by n summation over I equal to 1 to n xi minus capital A whole to the power r. This is the earth moment about capital A. And this set of observations being a collection of data without having any frequency, we have written this formula. And obviously, if we restrict this R, as here we have calculated as we have here defined the earth moment, if we restrict this R to any specific value, then we shall have the respective moment. Here the first moment about A, we have written, obviously we have to write in place of R1. So this is equal to 1 by n summation over I equal to 1 to n xi minus a whole to the power 1. So here I have written nothing. So 1 means nothing. The second moment, obviously in place of R we have to write 2. Here I have written that very 1 by n summation over I equal to 1 to n into xi minus capital A whole square. And if this set of observations be with having, if this set of observations x1, x2, so on, xn be with having some frequencies, as we have considered here, the observation x1 is with having frequency f1, and for this x2 observation the frequency is f2, and so on. Similarly, this xn observation is with having frequency fn. Then what would be the formula for calculating the moment? Now, how to define that then? This earth moment about A, as here we have defined the earth moment about A for this distribution without having any frequency. Similarly, in this case, with having some frequency, we have written 1 by capital N summation over I equal to 1 to n into fi into xi minus a whole to the power r. Fi are the respective frequencies of the observation xi. And capital N, why capital N? Because look at this. In this first problem, we have considered this n number of observations without having any frequency. That means x1 has appeared once, x2 has appeared once, and so on. Similarly, xn have also appeared once, one time. But here, in this observation, this being with having some frequencies, x1 observation has appeared f1 times. x1 observation has appeared f1 times. Similarly, x2 observation has appeared f2 times. So on, xn observation has appeared fn times. Okay, so how many numbers of observations are there? Obviously, that would be the sum of these all frequencies. Obviously, that would be the sum of all these frequencies. And so the number of data in this statistical observation will be the sum of these frequencies, and notationally we have written here summation over I equal to 1 to n into fi. This is capital N, and this being the total number of observations, I have written here capital A equal to 1 by capital N, the total number of observations, into summation over I equal to 1 to n fi, the frequency of the respective observation, statistical observation xi, into xi minus a whole to the power r. This is basically the definition of the earth moment, when the set of observations is with having some frequencies. Okay, now we shall recapitulate these raw moments. In this general definition of a moment, we have not been constrained to consider any specific real constant. In this definition of moment, this general definition of moment, we have not been constrained to consider this specific, to consider this real constant A as any specific real number. We are unbounded to consider any real constants as we like, we can assume. But if we constrain ourselves to consider this real constant specifically 0, then that very specific moment will be termed as raw moment.